Hi everybody, welcome back to my channel. It's Mrs. Maths here. Today we are looking at another exam paper question and we are looking at the Leaving Cert Higher Level 2019 paper. Paper 1, question 2. Don't forget that Mrs. Maths Ireland is also on Instagram and Facebook, so head over there and say hi. Don't forget to subscribe so you can keep up to date with all of my latest videos. Give this video a big thumbs up if you enjoyed it and let's get started. So the question is, the first three terms of a geometric series are x squared, 5x minus 8 and x plus 8, where x is an element of the real numbers. Use the common ratio to show that x cubed minus 17x squared plus 80x minus 64 equals 0. When you're looking at a geometric sequence or a geometric series, we use something called the common ratio, which we refer to as R. And over here in green you can see I've written some notes on that. Generally how you will find the common ratio is you put T2 over T1 or T3 over T2. So you put a term, any term in the sequence on the top, and then you put the 1 before it on the bottom. In most cases you're only going to have the first few terms of a sequence, so generally T2 over T1 will usually be the one you're going to use. I can do the calculation for common ratio two ways here. I can get T2 over T1 or T3 over T2. What you need to see here is that you have x's, you have variables, you need to create an equation, and they want that equation to be this one here. So what I've done is I've created the common ratio using T2 over T1. Then I've also created another version of the common ratio, T3 over T2, and I've written it here. And you can see here that I've let them equal to each other because the common ratio will be the same throughout a geometric sequence. It doesn't matter if you use T54 over T53, it still should be the same R value that you got if you did T2 over T1. So it's standard throughout the particular series or sequence that you're dealing with. These two statements are the same. There's several methods that you can do here. I'm just going to simply cross multiply. I'm going to have 5x minus 8 multiplied by 5x minus 8 equals x plus 8 multiplied by x squared. There is an alternative method here. We will end up in the same place, and that alternative method is multiply across by what is on the bottom. So multiplying across by x squared and 5x minus 8. It just depends on which way that you have been taught it in class. They will give the very same answer and the very same solution. I've cross multiplied in this question. If you multiplied across by x squared and 5x minus 8, we will end up in the same place. So both would be accepted there. I multiply out all my brackets. This would be a standard expectation that you are able to do this quite well at higher level. As I will say in all of these solutions, if you're finding something like moving around and multiplying out difficult, or you're finding you're making a lot of errors, you need to put a little bit of time into perfecting those skills. It'll make this stuff so much easier, I promise. Doing all my multiplying out, I'm moving everything to the left hand side here, and then I start to tidy up. Put the x cubed first, then the x squared, then the x, then the constant equals 0. Tidying up. What I've done here is I've multiplied across by minus 1 in order to remove the negative at the start of the equation. In our course, we like to present our answer when it is in equation form as a positive, so that would be a standard thing that you're expected to do there. This question was worth 10 marks. Part B of this question 2, they are asking us that if f of x is equals to x cubed minus 17x squared plus 80x minus 64, show that f of 1 is equal to 0 and find another value of x. So you have two jobs here. The first one is to do this, so let's start there first. We'll worry about the second job in a minute. When we look at this, they're telling us for the function of x, you're putting 1 in instead of x and you're letting it equal to 0. So we write out our function, but instead of x's we're putting in 1's and we work it out and we find that it is equal to 0. So we showed that that was true. We know that x equals to 1 is a solution or a root of this cubic equation. We could also then say that x minus 1 is a factor of this equation or function. I have if x is equal to 1 is a root, then x minus 1 must be a factor. Moving on to the second part, it says find the other value of x. When you have a cubic equation, you're asked to find all of its roots or just some of them. What you generally do is you find one root, usually by substitution. Now they give us that information here, so that job is done. Then you take that root, turn it into a factor, and divide it into the cubic equation. I'm going to do algebraic long division here. These are one of those things in this course. You either love them or you hate them. Practice makes perfect is the only way to get good at algebraic long division. So we'll go through it here. Now I have the solution done, but I will talk you through it. So again, I'm dividing in the factor, which is x minus 1, into the cubic. What you do is you take the x, you say x cubed divided by x gives me x squared. Now I multiply by what I just put up here. X squared by x, x cubed. X squared by minus 1, minus 1x squared. I then add these together. I change the signs of these two terms here. I put them in a circle so I know what I changed them to in case I have to go back and double check myself. I add them and I get minus 16x squared as the answer. You continue the process. We now take x minus 1, we divide it in here. So x divided into minus 16x squared leaves us with minus 16x. I now take minus 16x and I multiply it by the factor. Minus 16x by x, minus 16x squared. Minus 16x by minus 1 gives me plus 16x. Do the same thing. I'm going to add these two bits here together. Again, I changed the signs of the bottom bit, so I've changed that to a plus and I've changed this to a minus. I add them together, these will always cancel out, and I'm left with plus 64x. And then the third step then, again, once I've brought down this minus 64, I do the process all over again. Take x, divide it in, write out the answer, then I take the 64 and I multiply it by x, and I multiply it by minus 1, and I get that. Change the signs, add them together. What we need from this process is the quadratic equation that's left. We take that quadratic equation, we factorize it. You can use the brackets method, which is what I've done here, just for a bit of variety. You can use minus b formula here as well. Both are perfectly acceptable. I do find that using the minus b formula a lot, be it brilliant and it's great and it's nice and handy and fairly straightforward to use. If you depend too much on it, you lose the skill of factorizing, which is handy in lots of other parts of question. There's no harm in trying to do the odd bit of factorizing too. Keep it fresh. You can use the minus b formula here as I said, but I factorized x minus 8 and x minus 8. The solutions are the same. What we're saying is that the other value of x is 8. Put it into the space that they've provided. So we have found that the other value is 8. Looking at part C of this question, they are saying in the case of one of the values of x from part B, well, the values from x from part B is x equals 1 and x equals 8. The terms in part A will generate a geometric series with a finite sum to infinity. Find this value of x and hence find the sum to infinity. If we are to look back at part A, the three terms that we're talking about was x squared, 5x minus 8 and x plus 8. So what we're going to do is we're going to have a look and see, do they create a geometric series with a finite sum to infinity? I have actually found the exact terms of the sequence by subbing in x is equal to 1 into the first three terms, and I find that 1, minus 3 and 9 are the first terms of that sequence. I did the same with 8. I subbed it in and I found that 64, 32 and 16 was also another version that we could possibly have of a geometric sequence. I calculated the R in each one, which we call the common ratio, which is T2 over T1. In order for our geometric series to have a finite sum to infinity, we take the modulus or the positive version of the common ratio. In this case would have been 3, which is greater than 1. This particular sequence does not have a sum to infinity. We literally ignore the x equals 1 situation and we focus on this one here. x equals 8. So when we find the common ratio here, we find that it is a half. I get my information from this type of series, a being my first term, 64, r being my common ratio, which is a half, and I sub this information in and I find I get an answer of 128. This is something that you do need to remember. It is not in your log tables. The value of x that makes this happen is the 8, and then the actual sum is 128, and there was 5 marks going for this question. Geometric sequences and series is a common question that pops up in exam papers. I'm not saying it's guaranteed by any means because nobody knows that, apart from the people who make them. However, it does seem to be a favourable type of question. If this question in particular, when we're talking about the sum to infinity, is a little bit rusty, you're not 100% sure on it, maybe make the effort to go back and have a look at that in your textbook or your notes and revise it and be a little bit more familiar with it. That was the Leaving Cert Higher Level 2018 Paper 1 Question 2 Solutions. It was a 25 mark question overall. I hope you found it very helpful. If you did, give it a big thumbs up. Don't forget to pop over to my Instagram and Facebook page. I post there every single day and would love to see you there. Don't forget to subscribe to my channel so you can keep up to date with all my latest videos. Say hello down in the comments below and let me know how you're finding higher level math. Don't forget to share it with your friends, and I'll see you in the next one.